Okay, so the topic today is dealing with properties of logarithms. Now, the property of logarithms are similar in a way to the property on exponents because you get a log by just doing the inverse of an exponential function. They're just inverses of each other. So with exponents, where I have a to the second times a to the fourth, what would I do with those two powers if I wanted to simplify that expression? Yeah, add them. So then I would just say this is going to be a to the 2 plus 4. So that's a to the 6th. So with logs, so with exponentials, when you had two bases multiplied together, we left the base alone and just added the powers. Well, the way that looks with logs is inside of the log, you're going to have two logs times together. So if you wanted to expand this out, you're going to expand it out using addition, just like you did with the exponentials. So then when I write this out, I would have this as log base A and then of x, and then where that time sign is, instead I'm going to go plus, put another log base A, and then put the y. So with logarithms, we use addition to expand it out. Now, one thing to be careful, sometimes they get a little fancy. I just think if it's on the top of the fraction, you use addition. Okay, because in a second we're going to have division, and then with division, if it comes from the bottom of the fraction, we do something else. Okay, so with exponentials, if I had a to the fourth divided by a to the second, what would I do with the power of the 4 and the 2? Yeah, subtract is right. Okay, so then this would be the same as a to the 4 minus 2, which is a squared. So then with division on the logs, it'll be the same thing. When I expand it out, if I had a fraction, it's going to be subtraction. So then I would have log base A, and then the top of the fraction, which was an x, and then where the division sign is, then that's my minus log base A of y. So if it comes from the top of the fraction, it's addition. If it comes from the bottom of the fraction, it's subtraction. So these properties that I just barely used, these are on your guys' little reference sheet I gave you. So right down here. And then as natural logs, this is the way they look. And then again, I just think that's over 1. So if it comes from the top of the fraction, put plus, because they can get more complex things. We'll see some more complex stuff. So just top of the fraction, use a plus sign. If it's from the bottom, use a minus sign. Okay. Now, a property that I didn't mention is this third one down. And this one says if you have log base A of something and it's raised to a power, then this power rule says you can take that power, bring it in front of the log as multiplication. That's actually why when we were doing like these problems right here, why the answer ended up just being the power. Like, because I told you guys last time that these right here, log base A of A, like those are canceling out, it just leaves with x. Well, the reason it's just x, which was the power, is because really, using this rule that I just barely am showing you, this rule says if you have a power on something inside the log, you're allowed to bring that down as multiplication. So then when that log base A of A cancels and becomes 1, it's 1 times that x, because the power drops down. Okay, and then this warning, if you have log and then inside of the log it's addition between the two terms or subtraction between the two terms, you are not allowed to write that out as log u plus log v, because if you write it out as a plus sign, that meant that those really came from two things that were times together, not added. So we're not allowed to expand with addition or subtraction inside the log. It has to be multiplication, division, or powers. Those are the only things that we're going to be expanding out. Okay, so on this one, if it wanted me to expand, just show me in there like how many logs you think that I would have in my final answer. So show me number fingers how many logs we would have in the end. We do have 3 of the logs because I have 3 things that are like down on the denominator. I have 2 things being times together, and then I have 1 thing on the numerator. So anytime it's multiplication or division, we're allowed to expand out with logs. Okay, so when I expand this out, if it comes from the top of the fraction, it's a positive log. If it comes from the bottom of the fraction, it's a negative log. So that x comes from the top of the fraction, so its log is going to be positive. So I don't have any sign written in front of that natural log, which means it is positive. Okay, now on the denominator, that y was from the denominator, which means I now have to go minus natural log y squared. And then that z comes from the denominator of the fraction. So I again do a minus natural log z. Now my problem's not done because I see that power now sitting on my y squared. So then I use that property that says if I have a power, I'm allowed to bring it in front as multiplication. So my answer is natural log x minus 2 natural log y minus natural log z. And usually I would just bring that 2 down when I'm expanding it out all at the same time. Okay. But when you do bring those powers down, you only bring it down in front of the log of the base it was sitting on. So sometimes students will mess up because they'll put that 2 in front of all of the natural logs, but you only put it in front of the log that contains the variable that it was on. So if this had been written as the denominators like yz with both of those in a parenthesis to the second power, then I would put a 2 in front of the log with the y and the log with the z, but it would have to be grouped together on both of those. Otherwise, it's only on a single one of them. Okay, so the next one, show me in the air how many logs you think I'm going to have in my final answer on the next one. Okay, see about a... Okay, so it is 3. We have 3 things times together. So we should have 3 logs when we're done with this problem. Now, that fourth power is on everything, the C, the A, the B. So that fourth power could be brought in front of the log right away. So I can either bring that down and write it as 4 log base 2 of CAB cubed, or my other option would be to put each of these right now to the first power and use my exponential rules, which say, okay, if I have a power to a power, I'm allowed to multiply that power in. And I could write it as log base 2 of C to the 4th power, A to the 4th power, B to the 12th power. Okay, so that's one option, or bring the 4 down in front of all of the logs, and then when you expand it out, you'd expand it out with a 4 in front of all of the logs. Okay, so it doesn't matter which way you do this. Okay, now that I have taken care of that 4 one way or another, I'm going to expand this out into my 3 logs. All of these are like, if I made a fraction, these are like over 1. So they all come from the top of the fraction. So when I expand it out, I'm only going to be using addition signs. Okay, there's not going to be any subtraction on this particular problem because I didn't have any variables on the bottom of a fraction. So then this will be log base 2 of C to the 4th. But instead of leaving it as C to the 4th, I know eventually I'm going to have to take that 4 and bring it in front of the log as multiplication. So I'm going to do that right now so then I don't have to rewrite my problem later. And then I'm going to go plus, and then I'll get a log. Oops, I left off the base of 2 on my log. You have to make sure you keep whatever the base is. Always write that on each of the logs. Log base 2, and then this next one would have been a to the 4th. But again, I don't want to leave my power there because I know with logs it should go in front as multiplication. So I'm going to swing that 4 in front and not put it on the a. And then I go plus log base 2 of b to the 12th, but again, that 12th power, I don't want to leave it in front on the power. I want to bring it in front as multiplication. So then this right here is then my final answer. All of them have to have that log base 2 because that's the type of log it came from initially. Okay, this next one, show me in the air real quick how many logs there should be in the final answer. Yay, good. 4 is correct. Okay, now that root, I don't like to have roots. So I need to write that root as a power. And what power is the same as a root? 1/2. So I can say, instead of writing that as a root, I can say this is like all one great big parentheses to the 1/2 power. So now I can either do what I did on the previous one where I distribute that power in. So I can write x to the 1/2, y to the 1/2, z to the 1/2, w to the 1/2. Or the other option is, since all of those are to the 1/2, I can just bring the 1/2 down in front to begin with. and write it as 1/2 log base 5 of x, y, z, w. And then when I expand it out, I have to make sure that 1/2 log base 5 goes with every single one of those with addition, because these are like all over 1, so they came from the top of the fraction. So I'll get 1/2 log base 5 of x, and then I'll go plus 1/2 log base 5 of y plus 1/2 log base 5 of z plus 1/2 log base 5 of w. And then that whole thing is my answer. Okay, on this next one, show me in the air how many logs you think will be in this answer. Okay, so most of you are showing me 4. I saw a couple of you showing me 6. Those of you with 6, you're actually correct. It doesn't have to be a variable to expand it. It just has to be times together. So those 2 and the 5, those are being times to the x and the y and the w and the z. So those get to count as something that's going to get its own individual log. So we'll have a total of 6 of them. So numbers count also. So I have 3 things that are on the top of the fraction. So when I expand those 3 things that were being times together on the top of the fraction, I use addition. And then from the denominator, those 3 things that were being times together on the denominator, I use subtraction. So 3 of them will have addition, 3 of them will have subtraction. But they will all have a log base 7 on them. So then starting with the top of the fraction, I'll have log base 7 of 2. Then I'll go plus log base 7 of x plus, now when I do the log base 7 of the y cubed, I don't want to leave the cube on the y. Instead, I bring that 3 down in front. And the 3 will go right there, 3 log base 7 of y. Now I move on to my denominator, so minus log base 7 of 5 minus log base 7 of w squared, but I don't want to leave that square on the w, so I bring that 2 in front. And then I go minus log base 7 of z. So that big old long stream right there is my answer. Okay, on the last one, show me how many logs you think I'll have in this answer. Okay, I see most of you telling me 2. I think I only see one person that told me 1. You're correct. Okay, so basically the only thing I can do on this problem is take care of that root. I don't have inside of that natural log things that are being times together. I just have an x squared and a plus 1. I'm not allowed to expand out with addition or subtraction. So that all I can do is I can say, okay, I know that root is the same as a 1/2 power. So I can bring that 1/2 power down. So I get 1/2 natural log of x squared plus 1. I can't go any further. Even though there's a square on that x, I can't bring it in front of the natural log because it wasn't on like everything there. It was only on the x, it wasn't on the plus 1. I could bring the half down because it was on everything in that parenthesis. And then I can't expand that out because it's addition. Even if you had written this as x times x plus 1, I still wouldn't be able to expand that out because of that addition sign. Okay, the only time I could do a little bit of expanding if there was like addition or subtraction would be if it had been written something like x times x plus 1 with a log in front. In that case, I could break it into 2, one with the log and then one with the x plus 1, when it was 2 functions or 2 things that look like factors that were being multiplied together. But if they don't look like 2 factors multiplied together, you can't expand out at all. So that's that answer. Okay, now going reverse. Now we know how to expand. Now we want to condense. Condense means combine it into a single log. So the very first thing to condense it into a single log, you have to make sure they're all the same type of logs. So on this first one, they're all a natural log. On the second one, they're all just a log base 10 because there's no little base listed on any of them. So as long as they're the exact same type of log, you can condense it into a single log. So then the second thing I do is, after checking to make sure they're all the same type of log, is I look for any numbers in front of the logs. If there's any numbers in front of my logs, I bring those up to become the power first. But, you know, on this first example, there's no numbers in front of my log, so I'm not going to make anything become a power. So then what I'm going to do is I'm just going to go natural log. I only write the natural log once, and then I immediately just draw a fraction line. If it's supposed to be on the top of the fraction, it would come from a positive log. If it's supposed to be on the bottom of the fraction, it'll come from a log that has a minus in front of it. And then anything you put on the top or the bottom together, you just times them together. So this first one, my x, the sign in front of the natural log, if there's no sign there, it meant it was positive. So that x had to come from the top of a log. My y, if I look at the sign in front of its log, it was a minus. That means that y had to come from the bottom of a log. The next one, the z, the sign in front is a plus, which means it had to come from the top of a log. And then if I want to put a sign between the x and the z, at most I would put a little dot for multiplication. Do not put a plus sign. Okay. And then I look at the 3 and I see the sign in front of the 3 is a plus, which means that 3 came from the top of the fraction, and usually we just put the coefficients at the beginning. So I would say my answer is natural log 3xz all over y. Now it's all condensed. So on this next one, they're all log base 10s. If you want to see a base on it, that's fine. You can just go ahead and write in 10s. But I have no problem just writing them as just logs without writing in the bases of 10s. Okay, but it's not wrong if you choose to do that. Okay, so they're all the same log, so I know I can condense it into a single log. Now I look at the numbers in front of the logs. Those numbers need to become powers. I need to move them. So then I'm going to move it from in front of the log and make it an x to the 5th. And then I'm going to take this 2. I ignore the minus sign and I'm only taking the 2. So I take the 2 and put it right there. And then I'm going to take the 3, make it become a power on top of the z. Then I'm going to take the 4, make it become a power on the y. Now that I've taken care of the powers, I write my log once and then make a fraction. Again, if the sign in front of the log was a positive, then I put it on the top of the fraction. If the sign in front of the log was a negative, then I put it on the bottom of the fraction. So my x to the 5th in front of the log, there was no sign, which meant it was positive, so I put the x to the 5th on the top. W to the 2nd, the sign in front of that log was negative, so it goes on the denominator. Z to the 3rd in front of that log, it's negative, so it goes on the denominator. Y to the 4th in front of its log, it's positive, so it goes on the numerator. And then there's my condensed answer. Now, if for some reason I ended up with something that was like x to the 5th, y to the 4th over, and then I had like an x to the 3rd on the denominator, I would be able to cancel, like simplify those using normal operations. Okay, but in this case, they're all different variables, so I can't do anything. But sometimes it is possible that after you write them as a fraction, you might be able to simplify some stuff out. Okay, so on this next one, they're all natural logs, so I can condense this into a single natural log. But I again take the powers, the numbers in front, and make them powers. So that one, that was a half power. If I wanted to, instead of writing it raised to the half power, I could write it as a square root. If I had a 1/3 power, I could write it as a cubed root. Okay, so now I write a single natural log and write my fraction. So the x came from something that was positive in front of the natural log, so then that's going to be the same as it being on the top of the fraction, x to the 1/2, or if you prefer, we could write that as root x. Both of those answers would be correct. And then the x minus 2 to the 3rd power, it's a positive in front of its log, so that means the x minus 2 to the 3rd should be on top. Now, I didn't have anything that had minuses in front of the logs, which meant on the denominator, if I wanted to put something there, it would have been a 1. So I don't need to write that, so I could have just put natural log of root x times x minus 2 cubed. There's my answer. Now, the whole point of being able to like expand and condense, basically it all depends on what level of math you happen to be in. So for you guys, most of the time, if we are asked to solve an equation, and like if you get into Math 1050, we actually want the logs in the condensed form because it's easier to solve an equation with a log if you condense it all into a single log, and then it makes it easy to solve. If you have a whole bunch of logs, it's hard to solve that equation. So at your guys' level, we like it condensed into a single log. The whole point of teaching you guys to expand it out is because if you find yourself into AP Calculus, then in AP Calculus, we're doing things that are called derivatives, and derivatives are harder to do if you're doing a condensed, if the log's all condensed. It's a lot easier to do the derivatives individually if you expand it all out and then take the derivative individually on each piece of the log. Okay, so there are benefits or pros of being able to do it both ways. But for you guys just practice doing it both ways because that's a skill that's needed when you get up to calculus. But for what you guys will then be doing math-wise, you'll always just want everything condensed because you're not going to be doing derivatives until you get up next year into AP Calculus. Okay. Okay, so now if I wanted to write these logs in terms of natural log 3 and natural log 4, all you have to do is think of like operations you could do with a 12 that gets you a 3 or a 4. What can you do with a 12 to get a 3 or a 4? Yeah, multiply them. So I could say this is the same as log of 3 times 4, which means since that's multiplication in between those, I could expand it out as addition between them. So I could just say that's natural log 3 plus natural log 4. And now I did what it said to, write it in terms of natural log 3 and natural log 4. Sometimes they'll say, you'll see something where it says, oh, let u be natural log 3 and let v be natural log 4. So basically, you just expand it out in terms of what they asked you to. And then you say, okay, well, now I'm going to replace my natural log 3 with a u and replace my natural log 4 with a v. So then my answer would just be u plus v. Okay, sometimes they ask you to do stuff like that where they don't want any natural logs in the final answer. But you first have to expand it out using whatever numbers they gave you. Okay, so natural log of 0.75. How could I get a 0.75 using 3s and 4s? Yep, 3 divided by 4. So I'll just say this is the same as natural log of 3/4. So since that's division, I know when I expand it out, the top of the fraction gets the positive, the bottom of the fraction gets the minus. And then if I wanted to do this stuff where u was natural log 3 and v was natural log 4, I could say this would be u minus the natural log 4, which was the v. Okay, 64. How could I do that one in terms of 3s or 4s? Okay, so the two options, 4 times 2 to the second power and 4 to the third. The 4 times 2 to the second power is actually equivalent to the 4 to the third because if I use my exponent rules, I know I could distribute that 2 in. So that's the same as 4 squared times 2 squared, and 2 squared is the same as 4. So that's the same as 4 to the second times 4 to the first, which would be 4 to the third. Okay, so yeah, it was basically just figuring out what you could, either you could say 4 times 4 times 4 or whatever. So now that I know that it's the same as 4 to the third, I could write this either as natural log of 4 times 4 times 4, or I could write it as natural log of 4 to the third. Okay, either way, it doesn't matter. So then if I were to expand this out, that first way, since those all came from like the top of the fraction, I could expand it out using addition. But then I had 3 of the exact same things like added, so that would be the same as 3 natural log 4. If I did it this other way where we did it as 4 to the third, I could take that 3, bring it down in front, and write it as 3 natural log 4. So notice, regardless of which way I did it, those two answers came out the same. And then if I did the thing where I was plugging in u's or v's, I have a natural log 4, and up here my natural log 4 was a v. So then I would write this as a 3v. And I would leave that as a 3 because it didn't have a natural log 3 in front of it. It was just a plain old 3. Okay, now this, I've already told you guys about this right here, the change of base formula. So if you, again, find yourself with a calculator that doesn't let you do the log base, we could do this as log 8 divided by log 2, just using the log base 10 button. Or I could do the natural log button, natural log 8 divided by natural log 2. So as a reminder, log 8, close the parentheses, divide log 2, close the parentheses, tells me it's 3. If I did natural log 8, close the parentheses, divided by natural log 2, close the parentheses. Whoops, make sure that's a 2 though. It also tells me it's 3. And then if I did alpha window and did number 5 for the log base, I could just type in the 2 and the 8. I still get that it's 3. Okay, so the change of base formula, if you do end up having to use it, it's just log of the bigger number, like whatever number's written big, divided by log of the little base number. So this would be log x divided by log 2. And then this last one, I could do that as natural log x over, actually no, I can't even do that one. This one's written bad. That's not even a possibility because a natural log is a log with a base e. Okay. So that last one's not even possible. Okay, now on your calculators, if you ever see a problem where it says do a regression, it expects you to use your calculator. So the way you use your graphing calculators to come up with a regression line is just an equation that would fit the data. Now this one says specifically to do a logarithmic regression. So I should be coming up with a log equation that would kind of fit that data. So on the calculator, anytime it asks for a regression, you hit the stat button, which is right there now in red next to the arrows. And then I hit number 1 for edit. And then if you have a whole bunch of data in your list, I'm going to highlight list 1, hit the clear and enter button, and then it just wipes everything out. Now, if you mess up and hit the delete button instead, my list 1 just completely vanished. It completely deletes the list. So to get it back, I would have to hit stat and then number 5, setup editor, hit enter, and then it says done. Now if I go back to stat and edit, now my list 1 is back. So it's not gone permanently, but it just deletes the whole list. So don't use the delete button, highlight the list and hit the clear button and then enter. That way you don't get rid of your list. Okay. So now under my list 1, I'm going to enter in my x values. Under L2, I'm going to enter in my y values. Once I have all my numbers entered in, I make sure that my lists are both the same length. If my lists weren't the same length, then either I typed a number in twice or I skipped a number. And if that happened, I'd have to go back and look through and figure out where my missing number was or where my mess up was, and then I'd have to fix it. Okay, so you just have to make sure they end in the same spot. Now this one, it was kind of lucky because the problem said find the regression, the logarithmic regression. So it told me the type of regression I needed. Okay, so I can immediately go to stat again. And now I arrow over to calculate. And then I just scroll down until I find the one that says a log regression. So when I start arrowing down, I see a lin regression. That just means linear. If I wanted to come up with an equation of a straight line. Quadratic regression, if I wanted something with an x squared. A cubic regression, so a cubed root. Quartic regression, another linear regression. Okay, ln, natural log. That's going to be the one that I do because it's a log. If I scroll down, I have an exponential, I have a power regression, a logistic. Logistic is different than logarithmic. Okay, even though they both start with like a log, logistic is not logarithmic. The ln is the logarithmic. And then I have a sine. Okay, so I have a whole bunch of different options. So I just pick the one based on what it tells me. So I'm going to choose the natural log. Now it tells me my list 1 is going to be my x values, my list 2 is going to be the y values. If these were telling me the wrong things, let's say I had entered my stuff into, say, list 3 and list 4 instead of list 1 and list 2, I would have to change this to the appropriate list. So if I had the wrong list there, if you look at your numbers like number 1, number 2, number 3, above it in blue it has list 1, list 2, list 3. So if I had the wrong list, I would just hit the blue second button, and then I would hit the number 4, and then it changes it to list 4. So you just have to make sure that your equations are coming from, it's going to pull the data from wherever you typed it into your calculator. And then I go down to calculate and hit enter. And so now it gives me my logarithmic equation. So all I do is say y equals, I replace the a in the equation with a 0.984. And then it says go plus, and then my b I replace with a 0.3147. And then it says natural log x. So now I have my equation. So if I were to have graphed this data should have, this equation should have fit that data pretty well. So the way I could have graphed this is once I typed all the numbers into my stat plot, then above y equals, it's in blue, it says stat plot. So I could have hit second y equals. Right now my stat plot's turned off, but I can hit enter. It tells me the data is coming from list 1 and list 2. And again, if those were from the wrong stuff, then I'd hit second and then whichever list I needed using the 1, 2, 3, 4 buttons. And then it's going to graph them as little boxes, but if I wanted to, I could graph them as pluses or whatever. And then if I hit zoom, number 9, it says zoom stat. The calculator will just zoom into the information I typed in under my stat plot. Oops, but I also need to go to y equals and erase other equations I have in there. And then I'm going to type in my new equation, 0.94984 plus 0.3147 natural log x. So I just type in the equation I came up with. And then we can see that that fit the data pretty good. So that was a good fit. Now the calculator will do whatever type of equation you tell it to. Doesn't mean it's going to be a good fit. So if I went over to calculate and I'm like, oh, I want to do a quadratic regression, so I had chosen number 5. Yes, the calculator will give me an equation for a quadratic equation, but it doesn't mean that it's a good fit for the data. So if I went and typed that equation in under, say, y2, I'd get negative 0.0139 x squared plus 0.207x plus 0.8159. So then you can see the red, it did graph it, but it doesn't look like that data fits it quite as well as the logarithmic. Okay, so the calculator will spit out any type of equation you tell it to, but it's not always going to be a good fit, okay? Some equation types are going to be better than others. So if it ever tells you which one to use, make sure to use that one. If it doesn't specify which one you're supposed to do, then you basically look at the graph it and look at the points and see what type of equation model you think would fit the data the most. And then you just use the calculator to come up with it. Okay, and then the last thing, direct variation. So anytime you have like direct variation, inverse variation, these are like word problems. So with direct variation, we always have a k, which is a proportionality constant. They don't ever use the letter k in their word problems. You just have to know if you see the word variation, you have to add a k in there. So it says y varies directly as x. So if you saw something that says y varies directly as x, that would be y equals, and then you see the word varies directly, that means you put in a k, and then it said as x. That could also be read as y is directly proportional to x. So if you see either of those words, varies directly or directly proportional, you have to put in a k. Okay, so it says the area of a rectangle, so I'll let A be the area of a rectangle, varies directly, so then I say equals, it said varies directly, so I put in a k, varies directly as its length. So then I times that with the length. If the area is, so then it gives me some information, the area is 50 square meters, when the length is 10 meters, then find the area when the length is 25. So now it says, now I want to find the area when the length is 25. So it gave me like 2 bits of information. The first bit of information was so I could plug these numbers in and actually find out what K was. Once I know what K is, then I can solve for the area when the length is 25. So my A, I'm going to replace a 50. Then I have K, and then I replace my L with a 10. So then if I wanted to know what K was, we would divide by 10 and get K is 5. So my formula now for this area of the rectangle, I would take this 5 and replace it right there for the K. So my formula is 5 times L for the area of this rectangle. And now it says I want the area now when the length is 25. So now I'm going to replace that length with a 25. And then I get 125. And then my units were in square meters. So meters squared. So anytime they give you these directly proportional problems, all you're doing is reading through what they tell you to and making an equation, but you have to remember to write a K. Okay. And then they'll always give you 2 bits of information. The first bit of information is usually enough information to find out what the K is. And then once you know what the K is, you plug it in, and then you plug in the second bit of information. So most of the time, we're just going to be timesing these things together. But if they had used the word inversely proportional, inversely proportional would have been you divide by. You do your K divided by whatever it said it was inversely proportional with. So most of the time we're just multiplying unless it says inversely proportional, and then in that case we just do a division instead.